Hello, my name is Chad Bullard.
And I'm Ananya Kansal.
Welcome to our presentation on comparing chat methods for remote collaborative live coding music. At the start of the last academic year, we were challenged with enabling a remote collaborative music experience in response to the increased demand caused by the coronavirus pandemic. Having used some of the existing packages intended to enable traditional musical ensemble rehearsals and performances, we knew that internet latency introduced significant problems to the musical experience. To avoid these issues, we looked to live coding music, where sound events are scheduled to a computer clock and thus can be fully latency agnostic. As we prepared to approach this project, we noticed that much of the literature for remote collaborative live coding music systems utilized some form of chat method, but did not provide an academic reference for why said methods were chosen. We saw this as an ample opportunity to contribute to the academic field, providing future academics with a concrete reference for their decisions in study design.
For the software development, we utilized the Atom text editor and created our own installable package called CodePlay. The package uses the Fox.musical live coding language as a base and implements an auto-evaluator, allowing each script to run approximately every 5 seconds automatically. CodePlay synchronizes the running scripts to your system's local clock by calling a clock managing system called ESP-Grid. The CodePlay package also works in conjunction with the existing Atom package, Teleparty, which allows for remote coding collaboration between participants in a Google Docs style format. For the study interface, we use Cisco WebEx because of the already integrated chat features, as well as the ability to take control of a computer screen. This allowed for minimal technical complications with setting up the environment due to the fact that participants were already able to take control of a setup environment with the packages running. Our participants were recruited through email, and all participants were Georgia Tech music technology students that had existing musical training, as well as varying experience with live coding environments. The study consisted of a brief questionnaire that informed us of their musical experience as well as live coding experience. This was followed by a 30-minute tutorial to allow participants to familiarize themselves with their system and the Fox.language. language. They were provided with a walkthrough sheet as well as some common methods used in Fox.so that they could reference throughout the study. The participants were then asked to complete 2 performance tasks that were each 15 minutes long. In these performance tasks, they were only allowed to use one form of chat method, either audio chat or text chat. The study was concluded with a detailed interview asking the participants to elaborate on their experience with using both chat methods.
Regarding coordination and synchronicity, we found that audio chat provided easy synchronization of events through verbal cues, such as counting. It had the drawback of not being recorded in our setup, so messages that were missed or intentionally ignored could not be reviewed later. Text chat countered this, being recorded and thus easily reviewed later. Its notable drawback was that there was not as obvious of a notification system as there was with audio chat, so messages could be easily lost.
One major difference between the 2 chat methods proved to be the bandwidth of the information shared. In audio chat, participants were able to communicate quickly with their collaborator, which allowed for an almost immediate response. The ideas shared between collaborators were able to be easily conveyed through audio chat. For example, participants could hum musical ideas to each other, which text chat does not allow for. However, in text chat, participants were more intentional with their messages, getting their ideas across with shorter messages and less communication. Text chat also prevented a collaborator from getting interrupted mid-musical idea, allowing them to check their message after they finished implementing their own idea first.
For musical audio, we saw that audio chat enabled participants to convey musical ideas by humming or singing, with the limitation that every use of audio chat interrupted the musical audio of the performance. Text chat was notably silent for the entire performance, maintaining the integrity of the music, but the conveyance of musical ideas was much more limited. In conclusion, we found that text chat carried the benefits of time invariance, brevity and intentionality of messages, and musical silence.
Audio chat carried the benefits of coordinated synchronicity, humming musical ideas, and quick and detailed discussion. We would like to thank Dr. Jason Freeman for his guidance and help throughout the duration of this project, as well as those who participated in the study and helped us gain valuable insight. We would also like to thank Audio Mostly for granting us the opportunity to share our work. Thank you all for your time and interest in this project.